Welcome back. My name is Chris Sikora, and I'm going to go through exercise 9 today. And in exercise 9, remember this is a SIM class, SIM, C-I-M, Computer Integrated Manufacturing course. So up until now, we've pretty much just been using Inventor for 3D modeling. And now with 3D models, remember, there's additive manufacturing and there's removal manufacturing, and basically or subtractive manufacturing. And what we're going to look at today is subtractive manufacturing. Essentially, the 3D models come in handy because you could send them out to a 3D printer, build them, and that generally adds material. But here we're looking at how you would take a chunk of material and remove that shape from it. And usually use a CNC, a computer numeric controlled machine. There's basically there's the lathe type and there's the milling machine. And then there's also hybrid machines that do actually multiple things. Like there's some that have additive manufacturing built into it and milling capability. Most of you, or all of you actually, who have taken or who have gotten to this level in this class have had to have taken IMT 103, 104, which IMT 103 deals with learning the lathe, drills, uh, cutters, and measuring instruments and all that, the safety as well. And then the 104, which is the milling capabilities. Well, here today we're going to just look at milling. Next week we're going to take a look at the lathe. But in our shop we have multiple Haas milling machines, and basically we're going to learn how to output a little program from a 3D model that we built inside Inventor, bring it over into a product called Mastercam. Now Mastercam you're going to have to download. You just go to Mastercam dot just type in Mastercam through search. So here you can type in Mastercam, Mastercam, and HLE for Home Learning Edition. And then you should see right here, you can actually download the demo today. So make sure you go to mastercam.com for this. So here's the Home Learning Edition. There's several links and it's free. Just use your educational email address in order to access it. Just hit continue here, and on here you'll see where you could actually download it. Let's see, here we go. Request Mastercam demo HLE. Put in your name, your information, the community college that I teach at here. Okay, and any additional information, and it should just give you a link right there. You download it. The link is gonna look. Just to show you here, it will be an executable file. And let's see, downloads. There it is. Mastercam 2021 demo HLE. If 2022 is available, definitely try that one. But just double click on this and it will install. And the only thing it doesn't let you do, one of the biggest limitations is with the Learning Edition, is that you can't output the actual G code. So at the college, we actually have the full-blown licenses where you can actually work on this from home, bring it in, and then we'll actually touch upon it. Now with the current COVID situation, we're 100% online, so we're going to try and do simulations instead for this class. This class isn't really focused on sitting at a CNC machine all day. That's the 222 class, the 220 class. But anyhow, let's begin. First of all, we're going to model this up in an Inventor. So I want you to go to New, Standard I Part, and hit Create. Now, in the training guide that we've been working on, it does go through all the parameters on here. I actually have a better drawing, and I want to put that up there so you all can see it. And so like here it is. This is the SolidWorks basics. And I actually grabbed this out of my SolidWorks training guide. But that's what it's going to look like. It's just going to be like a fixture, a very basic fixture with just some pockets and a couple drilling processes. So we're going to learn how to do those. So let's begin. With the new part, go to Start Sketch, select the X, Y plane. Now some of you might wonder, like, well, isn't it going to be, like, how's that going to be when it gets on a CNC machine? Because remember, you have three axes, X, Y, and Z. If we drop it on this XY plane, it will land on that surface, almost as if you're putting it on a table. Okay, so select that. You have the ability to transform or rotate it, so it's not a big deal even if you get it on a different plane. It's very common, in fact. Go to rectangle. Now it's a 4x4 block and it's 1 inch thick. So click in this corner, drag this out, type in 4, hit tab on your keyboard, type in 4 again, hit enter, and now hit the front block here so it zooms to fit. Now we have another rectangle right up here. Just click in this corner, drag this out. This is 1.5, tab 1.5, enter. Let's go to the circle tool, and down here, click and drag out a circle and make that 1 inch. That's going to be a pocket now. That's not going to be a drilled hole. 1 inch diameter drill, no, we don't need that. This is actually a pocket. It's going to be flat at the bottom. Typically a drill has a tip, like a 118-degree tip on it. This is not going to have that. So you're going to want to make this pocket. All right, now let's go to the line tool and infer over here. Click and drag this out. Don't put any dimensions in. Drag this across. Oops. Make sure I got a couple of fragments in there. You don't want fragments in your geometry. I'm just going to delete that line and start over. There we go. And then basically you're making a triangle. And as we go to the drawing, you can see the rectangle, or the square actually needs to be a 1/2 inch off the top edge and a 1/2 inch off the left. So that's for positioning. This is 1.1, the hole here is 1.125 by 0.75. I'm just going to drag that over here, and so we can put these in. So go to the dimension tool, select this edge to this, and that's going to be 0.5. This edge to this top edge will be 0.5. You can hit escape. Now this needs to be aligned to that, so let's just go ahead and use this tool here, collinear constraint. Select this line here to that line. Now go back to dimension this edge to this edge, and again 0.5. Don't worry that it's starting to intersect. You'll see we'll fix that shortly. Let's add a dimension from this corner to this edge, and that's going to be 1.78. And then from this corner to the bottom edge, these are actually going to be theoretical sharp corners. So 0.941, they're going to disappear, but the dimensions are clear on this. Okay, now let's go to the fillet tool, set the fillet radius to 0.25, and select all 4 of these corners and the 3 on the triangle. There we go. All right, go back to dimension and let's position this now. So select the center point to the bottom edge, drag that out. And we're going to lay these out a bit better in a second. 0.75, and then the center point to the right edge, click here, 1.125. Now hit escape, and let's lay these out so that they're easily seen and interpreted. That's the whole idea when you make a drawing. You want to make sure that it's easy for someone to read who's going to sit down and look at this. Okay, that looks pretty decent. Now there's 2 holes that are going to go in there, but let's get those later. Those are going to be, actually, we're going to use the hole tool inside the software. So now go to 3D model, go to extrude, and go to the home button. Now you're going to select the 3 centers and then outside. Oh, actually, no, we don't want that. If you shift and rotate, actually hit escape. Hit escape a couple times. Let's try that again. Go to extrude. I'm sorry, we just want this. And this is supposed to be 1 inch thick. Go ahead and hit OK. Now go ahead and go to extrude, select this face, and we could just go to project, select the face, and now we could go to extrude again. So go to 3D model, extrude, and now we actually want to select those 3. So I'm going to select this profile, that one, and that one to fill it, and then drag it up. Now it's going to want to remove material. Make sure you get it to 0.5, but right now it's set to cutting material, so make sure you join it. And so now we've made our block, because those are not through holes. Those are pockets. And go to isometric, which is the home button. Now we're going to add there's a 1/2 inch hole that's 0.75 deep here, and another 1/4 inch hole that's 0.75 deep. We're going to use the hole tool. Just going to rotate this a little bit. We'll go with the 1/2 inch first. So go to hole. Now make sure it's set to simple hole. Make sure seat is none. And we have it set here to distance. Now these parameters, this first one will add 3/4, 0.75 deep, and then it's actually 0.5. All right, now select right about here on this surface, and you'll see it's located. Now go to sketch 3 up here, and this lets us position it, so we could go to the dimension tool and click on this center to this edge, drag it down, and it's 0.75 off that edge, and then click on that center again to the bottom edge, and that's 0.75, and hit finish sketch. And look at that, we have our hole. Now what's neat here, look at that, there's actually a cone, the 118-degree cone that you see on a drill. All right, now let's add the next hole. Go to hole. This next one is going to be 0.25. We might actually see it here on the list. There it is, 0.25. And 3/4 deep. Make sure it's hole and seat is none. And select right about there. Go to sketch 4 and go to dimension. Select this edge here to this edge. Drag it down. That's going to be 1.25. And then select the center point to the bottom edge, and this is going to be 1.375. You could hit finish. All right, our part is done. Let's save it. Go ahead and save it wherever you know you're going to be able to find it. This is going to be E9. Hit save. Now, after you've installed Mastercam, you start it up. It takes a little bit of time, but it should look like this. Now, just to show you, our goal with Mastercam is this ultimately, where we could see the process. And this is a simulation. Let's go all the way back and hit play. And you can see it's showing, there's the actual tool. Right there, it's an end mill. It's a 1/4 inch end mill, and it's milling out those pockets. And it's finishing it. And then there were the 2 drill processes, which we set it to peck. For chip break, so it would actually break the chip off so we could go with very high speed. Now, you'll see one of the reasons why simulation is so important. The AI built in the software, it does a darn good job, but from time to time there's things like this fragments, and you want to be able to fix those. We're not going to go into all the details. Again, this class is just scraping the surface, but some simple adjustments could actually improve that and fix that. If we have time, we'll go ahead and take a look. But that's our goal, is to get that set up this way. So I'm going to go ahead and close this. And you can see here's the tool paths and such. Let's go to open and find that part, E9. There's mine. And I'm not going to save that last one. All right, should come in like this. Now, the first thing we need to do is select the post or post processor. Where that's located, it's under machine. Now, what a post processor is, or you'll hear it out in the shop, we'll call it a post. A post is basically a little program that adjusts the output for the specific machine. Figure every machine, many of them work off of the Fanuc language, which was been around since the 70s, maybe even late 60s. I'm not entirely sure when it was formed, but basically CNC machine, since the infancy of CNC machine. Now there's other types out there too, but pretty much Fanuc is what we're going to use. We're going to use a subset of that for our Haas. And so with that in mind, there's variations to it. Just like you have accents in different parts of a country, each machine has its own accent with its language, and you have to inform the software so it knows to output it with that accent, so it speaks the same language. Anyhow, when you select machine, you get to select from a variety of machines. Here you go to mill. Now there's default, and then there's manage list. What you can do, whoever manufactured your machine, usually they'll have a post available, or sometimes you could get it through your Mastercam reseller. Either one, contact them if you need that specific post. We're going to go with the default, which is basically very simple, the original language. Okay. Now, you'll see once you select that, you'll get these options in the toolpaths browser on the left. Hit the little plus symbol next to properties. And first thing we want to do is set up our stock. Because right now we do have the stock, but this is after it's been finished. We want to set up what type of block of material do we need. And we're going to make this out of 6061. So just like our last exercise. Let's go to stock setup. Just click on it. Now right here, you'll see X, Y, and Z, and you can put in parameters. So if you have specific parameters, you're able to just plug them in. We're going to just click on all solids, and it's going to look at our model and make it fit. It'll make it to that exact size. Now be aware there's facing processes and things like that that you generally want to go through, but we're going to pretend that that was already done to this block. It's very accurate at 4 inches by 1 inch thick. Now, we could type in and add a little bit of material onto it if we wanted. We're not going to do that right now. Again, when you get into the 220 class, that's where they start going into a lot more of those details. We're focused pretty much on the simulation currently. All right, so we've hit that. Now let's go to tool settings. Now here's where basically you're setting up your tool and the material type that you're going to approach. Now, this is also what these softwares typically do. They have their own little algorithms built in that will give you some default feeds and speeds. Again, those of you who've taken 103, 104 know what feeds and speeds are. You could look them up in the machinery's handbook, depending upon the material type, and it looks at your drill or your tools, like if it's just tool steel or if it's actually coated or whatever you're using. It can vary greatly. Of course, coated tools can go a lot faster in cutting. They have longer life expectancies than typical high-speed steel. But we're just going to go ahead and leave the tool alone. But instead, we're going to specify material. So go to Select, and you'll see over here, you could go, instead of mill current, go to mill library. And they have a selection of materials. And you could, it's my understanding, you could purchase additional libraries of materials if this is all you have, or you can make your own. And we're going to go with 6061 again. And we learned from exercise 7 a little bit about 6061. It's an aluminum. And it's pretty strong aluminum. But anyhow, we're going to go with that 6061. Hit the green check. Now what it's going to do is it's going to give us some default settings for the feeds and speeds, like I said earlier. Now remember, the feeds and speeds that typically you'll find in a CNC or software like this, they're going to be very conservative. When you're in the shop, there's other variables, like I said, different types of tooling and such. This does have a lot of technology that you could tinker with and put in your own database of technology. But just as a heads up, it's going to be very on the conservative side, whereas when you're in a production environment, you need to get that thing running fast. The whole idea is to get these parts out as fast as possible without breaking tools, with as little tool wear. You want to find that balance because that's money. And you're going to make your boss really happy if you could get these things out. But remember, you don't want to be breaking tools all the time. All right, so let's hit the green check. Now, we're looking to add, we'll first add the drill processes. So you could go here, or you could right click right over here, and you'll see from milling, machining, but let's just click on drill. Now, in this version, and I'm not sure if it's just the install that I have, or I might have a lot open and running because currently I am recording. It seems to be taking a long time, so just be patient. Don't click. It might just be this release. I know previous releases, it seemed much faster when bringing up this information. So just give it a minute before you start clicking on things, because I do believe it's just thinking here. And I might actually pause it. Oh, there it goes. All right, didn't even have to pause it. It just took about 30 seconds or so. All right, so now here's where we get to select the entity. So we're going with the drill process. And to rotate this, unlike Inventor, you remember Inventor was shifting the wheel. This is just the wheel. Push it down, hold it, move your mouse left, right, up and down. You could rotate. Now go ahead and select this lower edge. Now be really careful when you look in this pocket. Make sure this edge glows, because that's what you're going to want to select. You don't want the upper edge, or else it's just going to stop right at the top there. You want it to go all the way deep. So click on that. You'll get a little red cross, and that's good. You can hit the green check mark here, and now it brings up the properties here for the. So we're set to drill. We're going to go to tool here, and now again, it's taking a while on my machine. Not sure why. If it's taking a while on yours, just sit back. I noticed if I click too much, you might escape out of something too early before it's finished. So I'm going to pause while this comes up. Okay, it took about 25 seconds, I counted. So again, it just might be on my system. Now what we want to do, never go with the default tool that it gives you here. That's not what we're looking for. We're putting it on a 1/2 inch, so we need a 1/2 inch tool. So click on Select Library Tool. Now there is a filter right here. You could click on Filter, and just so you don't have to see all the tools that are in there. And remember, these are tools in their technology database. You may not have all these tools, so you could customize it to what you have. But in here, I'm going to hit None, but then I'm just going to select, let's see, Drill right there. I'm going to hit the green check, and that will only give me the drills. Now we have to look for a 1/2 inch, and it goes in the increments as such. And so let's just scroll down here. We're getting, there it is. It's tool 162. So the 1/2 inch drill. Hit the green check. Now you could go to the holder. Now why do they have the holder? The reason they have holders is because when they do run these simulations, sometimes you can actually run the whole machine inside the simulation to see if there's anything that's going to hit. Because remember, this is automation. These are basically machines that are moving, and you don't want them to crash into each other. All right, but we're going to leave that alone. We're going to go with the default holder. Now go to stock and select use stock for the define stock from. We'll go with stock setup there. Now the cut parameters. Now here you see drill and counter bore. Go ahead and select chip break in this case. And this is going to plunge it at 100 thousandths and then bring it back up and then plunge a little bit more. So actually, it's going to pop it up 100 thousandths. And what that does is it breaks the chip. If you've ever seen when you're drilling, sometimes the chip is rather long. Doing this can actually break that off. And so if you ever have problems with your drills breaking while you're drilling in the drilling process, try the chip break or peck. All right, now the tool axis control. We're just leaving it 3D axis format. Limits, we don't need to set any limits here. Now let's go right to coolant. Now there is things like safety zone and things like that. We're not going to go into that type of detail here. But go to coolant, and you generally want to run coolant to prolong tool life. Allows you to run much faster your process. Hit the green check. All right, so that's our first drill. Now let's do another one. Go ahead and click on drill again. And this time it came up much faster. It was obviously loaded. And now we're going to select the bottom of that hole there. Click on that. And this is a 1/4 inch hole. Make sure that red crosses there. That looks good. Hit the green check. Now we're going to go to tool. And again, it's probably going to take about 25 to 30 seconds. And from here, I'm going to avoid hitting my pause button. For some strange reason, last time I hit pause it a couple times inside of a video, it actually changed the sync on my as I talked, so which is really annoying. So I'm going to wait. It's only a few seconds. Okay, now go to Select Library Tool, and it should still remember with our filter the drill sizes. And here we're looking for a 1/4 inch, and goes by size. So there's an 1/8, so we know it's coming up pretty soon here. There it is, 1/4, and it's a tool 124. Go ahead and hit the green check. And now let's go back to stock. You'll see it will remember from the last choice that we made, so that's good. Let's go to coolant, and it remembered the coolant. It even probably remembered the packing too. So go ahead and hit the green check mark, and there's that. Now we could just simulate those two and see what happens. So up here at the top, click on Select All Operations. And let's go ahead and go to Verify Selected Operations. Now it's going to bring up this tool here. And hit play. Okay, and there you can see it's actually pecking. And it left us with our holes. I'm going to go ahead and close that. So now we want to go ahead and add some of the next thing. So if we go over here to 2D, now there's several strategies. Let's go to Pocket. We're just going to keep it very simple. And again, we'll give this a minute. Again, it's taking about 30 seconds when I've counted, 25 to 30 seconds. Yours might not be taking that long. Now notice while we're waiting, there's 3D. Now 3D gets a little bit more advanced. That's for contoured shapes and things like that. Can you do a pocket? Absolutely. There's more setup involved. As you become more advanced, you'll find yourself using a lot of those tools. Okay, so right now we have it set to face. So select the floor of each one of those pockets. So there's 1, 2, and 3. Make sure they turn yellow and hit the green check at the bottom. Now we have the toolpath type. We have it set to pocket. Go to Tool. And again, it's going to take a minute here. And as I was talking before, you have 3D and you have multi-axis. We will not get into those. Those are pretty advanced for this class. Again, this is just a basics class. But those can do amazing things. Those of you in our program may be aware that we actually have a 7-axis machine and we have a trunnion on our Haas for 4 and 5-axis milling. So while we're waiting for this, basically you have your typical 1, 2, 3 axes. But this allows, like for example, articulation around and up and down like that. Okay, anyhow, so now we're going to go back to Select Library Tool, and we want to go to Filter and turn on None, and then we're going to go with the very first one, End Mill Flat. Hit the green check, and now we're going to go with 1/4 inch because our radiuses were 1/4 inch. We'll go with a little smaller. We could go even bigger, I suppose. We can maybe go 3/8. Let's try 3/8. Hit the green check. Have a little fun with things. Sometimes give it a try. See what it is. This is a simulation. It doesn't hurt anything. Okay. So now that I have that set up, actually, I take that back. I don't want the 3/8 because that was the 1/4 inch radius. That won't fit. So let's scrap that. Hit Select Library Tool, and let's stick with the 1/4 inch. Hit the green check. Okay. Now we could go to Holder, and you'll see similar holders you could choose from. Cutting parameters. Now you can see if you want it to climb or conventional, how you want it to mill out this pocket. You have standard, facing. Again, we're not going to go into all these details. Now the stock to leave on the walls, that's for roughing. So when you go over the finishing cut, there's a little bit of material on there. It can make a nice smooth surface. We're going to cut in a little bit deeper. Let's go with 10 thousandths. Roughing. We have all these other options like step over distance, percentage. And now notice you have high speed, parallel, constant, zigzag. Let's go to, we'll just leave it as is. And finishing, we could have, maybe if you want, we could put 2 passes in. Maybe you want it to try and smooth it a little bit more. Depends on how fast you're going. Machine finish passes only at final depth. You could adjust and override the feed rate. Now this actually is very important because, like I said, when you get in an industry, these settings are a bit on the conservative side typically. You might want to speed things up a bit. Your boss might want you to, and they usually will have ways to do that, but you yourself can, once you feel more comfortable, you can try this out. But anyhow, so let's go ahead and we'll turn coolant on. And there it is. Let's go ahead and simulate it now. Go to the top here, just select all operations, hit verify select operations, and I'll hit play, and it will do all of the operations. And you could even zoom up on this and see in detail what's going on. Now, when you want to output this program, you click on G1, and that's where you're going to see with this HLE edition, you can't do it. So you are able to save this though. You would basically save this, and those of you in this class, you could bring it up, bring it to the school, and we actually have full-blown licenses of the software with the proper post, and you could output them. And the hope is once this COVID thing blows over, we could go in and actually run some of these things on machines. There's more settings involved than this, by the way, but this is just an overview. And that concludes exercise 9.